Hi, let's work in another case. So from the previous one, remember 2D, now we move to 3D. So we're, let's say, halfway. So basically this is what we're going to do. Okay, we have this geometry, fully 3D, we have our boundary layer mesh and everything, and we're going to use the same setup. Okay, so I'm going to show you the whole workflow using two different applications to create the geometry. So here I already have it, you can download it. So we have one using the same modeler, then the space cleans, that probably is the friendliest one. And then also I'm showing you how to import the geometry, okay? So the same modeler, it is a CAD software, but it's not state of the art. If you want to use a fully parametric CAD software, it's better to use something else. So in my case, I use this, okay? This is what I use on shapes, which is very friendly, so fully parametric. Here I create a geometry, then I export it, and I import it in Ansys Workbench. But let me show you how to create the geometry in the same modeler. So add a new here geometry, open it. I have it already here, and let's do the solid. Okay, so also you can download the dimensions. So here we have the drawing here with all the dimensions. Again, I generate this using Onshape. So pretty much it is exactly the same as the previous one. Okay, just we have the circle here to the distortion, but the dimensions are the same. So let's go like we proceeded in the previous one. Let's do it here. So I will sketch in this plane. I will add sketch here, then let me go to settings and put the snaps, okay, and let's work in this case in meters. Okay, so for that also let's change this grid, okay, because the dimensions are small, so you will zoom in and then you have your grid there. Okay, so let's do the first one. So like we did in the previous one, just put it here, okay, then we can add dimensions. So here is 0.2, okay, I have good eye. 0.1, okay, that is okay. Then we need to create this section here of the elbow. So remember that we have here the center of a circle, and then we can create that part. So let's create a construction point. So I will put a point here. So that one I know it is 1, but remember to always add your dimensions. Okay, here I don't see well, so I will hide the grid. Okay, and leave this snap. So it's a vertical, okay, from here to here. So you select 2 with control, V3 0.1. Okay, so this will be our center for the circle. So remember, there are many ways to create a geometry. I'm choosing this way. That might not be the best one, but there is no problem. Boom, one circle, center here, there. You see the C means that it's centering, and the P means that you are attaching that one to this point. Okay, from here, let me create this line. See the H there? That H means that it's horizontal. And then the C means that you intersected the circle. So you have this line here. And now we can go and create the other segment, this one. See the V there means that it is vertical. I can do the same here. I have it there. And now let me probably I can connect these two here. Connect, yes, they are horizontal, they are in line. And now let me modify. I can trim, so I don't want this, 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 neither this, and voila, we have the shape with all our dimensions. Well, we need to also give dimensions there, but I was using the grid. So general. Okay, see that is larger than I thought, 0.2. Okay, so see that here we have a problem. I have a problem how I'm giving the dimensions. So let me redo. Let me raise. So this is important, the order how you put your dimension. So here is moving this point, so I don't want that. So let me raise that dimension. Okay, it will be dimension. Okay, general. Okay, here, right click, delete. Okay, I can delete here. And let's delete also this one. Oh. Okay, so we have that segment. I need to leave this line here, so probably let me create a rectangle here. Okay, so now I can go general, B1, B5, 0.2. Let's see if it's okay. Okay, so I see that different combinations can give you different outcomes. So now go modify. I will trim this and this. I don't need it. Okay, and I think pretty much this is okay. You can also add the other dimensions, but this everything is fully constrained. So now remember, we can use that sketch to create a surface. Apply, add frozen, and generate. So we have this. The next step will be, okay, remember that we have this small inlet here, but let's create this section. So to create the 3D solid, what we're going to do is create here a geometry, a circle, which will be the section, and then we can follow this path. I think, okay, let me see. Okay, I think I will need to do a modification. I will show you. So something important, important concept is that we need to use support geometries. So see that if you want to sketch in a plane that is passing through this point and normal to this line, you need to generate that plane. So that is called support geometry. So you go here, new plane. Here you have the option type, and I want point and normal. So you go select a point, apply, and then select normal, and then see that there you have your plane. Generate. We have our plane, and we can go sketch there. So now we can sketch the circle. So this is the part that I don't like about this one. Sometimes you need to use the geometry, reference geometry from other sketches. So it's not straightforward how to get those support geometries here. So you will need to create it. So as you go here, we're in sketching, I will create a line. See the P there means I'm in that point, and there is a C there, you don't see I'm in that line. Okay, so let me give a dimension, which will be 0.05. So this is the center of the circle, so this point is attached there. Boom, and then there is a P there, so now I attach there. So we have the circles. You want to be sure, you can add dimension there. It tells you that it's over constrained, it doesn't matter. You have 0.2, and what you can do now is just use it as a reference. So you should select something else. Go here, right click. Okay, no. Reference only. Okay, you have it here. Okay, the dimensions only a reference. So we have that part there. Just your circle. So now we can create again surface from sketches. So make sketches this one. Apply. Out frozen. And generate. So what we can do now is use this face and follow this path. Okay. Let me see if it is selectable. Maybe it's not selectable. So here you see that you have many options to create solids. So we're going to use sweep. You select the face, and then we can select the path. Okay, see that. Select this one down, Control, select the other one, and Control, select the other one, the green here. Apply, we'll select it, and voila, we have the solid. Okay, so remember to do this one, that line, the path needs to be attached to this one. If it is not attached, it won't work. Okay, so we have this part of the geometry. The next, let's create the pipe. So that pipe we created here in this plane. So we can create is, as we're going to create a new geometry, let's create in a new sketch. So we have the sketch there. Go into sketch mode. So you have that geometry there, you can hide it. Okay, I don't want to see, hide body. Also, well, it's okay, we can leave the surfaces, or you can hide the surfaces also, hide body. Okay, so we're working here. And what I'm going to do is create a vertical line here. See the B there, somewhere is a vertical line. And I have some dimensions. So I have this distance is there, the center. So I will go here, dimensions, horizontal from here, control, so that the second one, and put your dimension that it was 0.1375, if I would recall. Yes, and the other one to send. So from here, we are going to add a vertical one from here to here. And that one was 225, so it's vertical 0.225. So see that we have this line. So this one will be the path that we're going to use to extrude a circle to do this sweep, or we can use a normal extrusion. But the idea is that we're going to use this point here to create a plane, and then we can sketch in that plane. Okay, so this is a reference geometry. Okay, we're done here, and see that we need to create a support plane, okay, because here doesn't exist that plane to create my new geometry. So you go into create new plane, as same as we did previously. So it will be point and normal. Your point is this one, and your direction is this one. Apply, generate, and we have the plane there. Okay, so we can go and do the sketch here. So all the sketches, you see that, you don't see that, so you need to make them visible. So you go here, always show a sketch, okay, and you will see your other sketches if you want to make them visible always. Okay, so just making them visible. So now in this plane I want to add a new sketch. And here I will just simple sketch a circle in that point, and then we give the dimensions. So diameter 0.025, I will recall. Yes. Okay, and we can create now surfaces from sketch. This sketch is this one. Apply, add frozen, generate, and you have the surface, and then you have to do two actions, or this the sweep, okay, or this normal extrusion. Okay, so the sweep will select this face and follow this line. The normal extrusion is something linear, so you select the face and then give a distance. So see that here is pointing in this direction, so let me change this one. See here, you see it, so you can change, reverse the direction here, direction, reverse, and you have it there. Okay, so you can make it longer. And so do not add material, okay, so add frozen as usual, and you have it there. So if I show my previous body here, see that this is what we have. We have these two bodies, and now remember, before going to mesh an application, here we need to have one single body. So let me suppress the surfaces. I don't need them. Also suppress, okay? You need to suppress everything that you don't need, and ideally you need one single body there. Okay, so what we do here, because we have two parts, so we can do a Boolean operation. Okay, so I can come here and you have Boolean. I can do the union of this and this. apply. So you have different actions here. Okay, what for us will be union, generate, and now we have a single body. Okay, so this body, it is okay to use for the mesh. Remember, everything is parametric, so all the dimensions that you created there, you have it available, so you change something and will change automatically. So for instance, I can change, let me see, okay, that support line, for instance. So I will go and I will change B7, I will put here this value, and you press generate and see that it's updated automatically. Okay, so this is the advantage that everything is parametric. So then you can use design, space exploration, study, very easy. Okay, so we have this, but remember that we're going to, I show you in Fluent that it was half the body just to save the symmetry, just to save mesh elements. So we can split this one. So let's do the split. So again, we have another operation here. You go create, you have a slice, and you can slice this body using what? A plane, and I want to use this plane. I know that this is my symmetry plane. You can slice all bodies or select a single body. So you go select it, select this one, apply, boom, slice, and here you see you have body 1, body 2. Okay, so let's suppress this one, and we have just this one. You change the names you want. I will put domain, and here's solid fluid. So here we have this geometry, and now we can use this geometry to do our mesh. Okay, so now I'm going to show you the other source space claims to do this geometry. You will see that it's much easier to use. Okay. Okay, so after you finish your geometry, just close it. So here I have it. Okay. So I will delete this one. Okay, we already have it set up here. But now let's work with space clean. So I pull another geometry here, and let's do the same geometry with space clean. I already have it here. So when you go in space clean, you are here. So let's go 3D design. Okay, and again we need to choose a plane to start to do the 2D sketches, and then we can do all the operations to create the solid. The big difference with the space clean is not fully parametric. It is a solid modeling software. Okay, sometimes you have to use a Blender, stuff like that. It's something like that. Okay, you don't have the history here, but the big advantage is that you can take any geometry and you can modify it just by pushing and pulling edges, faces. Okay, it's very friendly to use, very easy to use. So let's do this in geometry. I go here, sketch. I want to sketch using this plane, make it normal, and here you have all your options to do your 2D sketch. So like in the previous case, let's do it. So you will see here that this one is much easier to use. Okay, so here we have it in millimeters. So let's do it there. So then we can do the scaling. Remember, when you pass to Fluent to do the scaling, I will leave it in millimeters. So you see here that you press tab and you can choose the dimensions. Okay, so I'm here in the horizontal. I will put here, okay, let's go, I think it's 200. Okay, probably, and okay, 200, and then choose the other one. You press tab, 100. Okay, and see that here you have your geometry. Okay, you can do the same for the other. So let's create also a line here. Okay, to have my reference line, and will be 100. Okay, you have 100 there, and then I can start to sketch the circle. One circle here, the other here. Okay, then I can go and put a line here, intersect with this one. See that you have the trim action here. You already realize that this one's much easier than the same modeler. Okay, and now I will throw the other vertical line. Okay, so I probably can go and put a rectangle here, up, no, and then from here to here, it will be 200. Okay, voila, we have it. I can trim here, another trim, and voila, we have the 2D sketch. See that we go back to 3D mode and we have the surface. The beauty here is that every single this solid that you can create then using the pull, kind of a universal function. So you can pull this, then you can take this face and probably revolve it about this edge. Okay, so it's very powerful. Okay, I love it, but sometimes you need more control using a proper CAD software like this one. Okay, but in any case, let's do this geometry using this software. So now that I have this, we need to create again a support plane to do the sketch here. So to create that support plane, we have somewhere, I forgot, we have the option at plane here. Okay, plane, and this is very smart. If you click in the vertex, this is your plane, and then you can go, I want to sketch where, here. Okay, and see that you see there in transparent you have your geometry, and see that triangle in the middle is the mid position. Okay, so you go there, snap there, snap there, and you have it there. This is your circle, and voila. So again, this one is you can push, pull, but we want to use a sweep here. So the sweep, this is the universal one. So sweep, it works like this. Select the face, and then here you have the path. Sweep, and then you select the path. This, and this. Put it there. Oh, okay, it's control. Okay, select the path. Control, multiple selections. Okay. Pull. Okay, you selected the face, and then 1, 2, and 3. Okay, see that is blue, and voila, you have it there. Okay, so the next step will be to add the pipe. So to add the pipe, okay, so let's see how can we do. Okay, so I know the distance, so let me go here. So I know this distance. Okay, cool. So what I can do, okay, and you will see that I can create here. Okay, I have that line there. Okay, so let me create an sketch here. I will show you how powerful is this. A circle here, boom. Okay, I will do pull here, so this is not related to this geometry, and see here what I can do is here pull here, and I can have my diameter. So I know that the 0, what was the radius? It was 12.5. Okay, so 12.5. Okay, so you have that pipe, and now somehow I need to put it here, align it with this body. So see that here we have the move option, so you can select the whole body, and then you're gonna start to move it. Okay, select the axis. Okay, let me select the body here, body, and then move. Okay, you can move. Okay, it's very powerful. Okay, you need to get used, okay, how to use it. So we have it there. Now we need to align scenes. So I know that this pipe, it is, I can measure distance. So here you have measure. So this pipe, this diameter from this one, it is a distance of, see, so in my case, it has to be a distance of, okay, 137. So what I can do is a move here. Okay, so I go, by the way, I'm not doing this in the best way. Okay, so I select this one, then select this axis, and here you see you have many options here. So select the ruler, and then I want reference this one or this. Okay, you have it there. So that one, the distance was 35. See, that was automatically move. And I can do the same with this one, the bottom. That went from the bottom to that reference was 2 to 5. Okay. Here. Okay. So here in this case, I would like to move this face. Okay. Up or down. Okay, but okay, let me move the whole body. Okay, okay, so Control C. Okay, pay attention also. Okay, so for instance here, if you do this pull up operation, it will automatically merge. Okay, so you don't want to automatically merge, choose here no merge. Okay, and you're not doing the automatic mergings. This is kind of the frozen. So I was doing, okay, let me move this pipe. Okay, and I want to move this face of the pipe. See that I move the center. I want to move in this direction. The ruler will be this one in reference to this point. Okay, and it was 2 to 5. Oops, 2 to 5. Okay, let me see, didn't move the body. Okay, so yeah, move here. Okay, it's not moving the body. Why is not moving the body? Okay. Okay, yeah. Okay, I was selecting just the face. Okay, so move it, attach it here, and apply a roller here. Okay, I'm making it look harder, but it's not that hard. I just choose the run. Okay, I need to attach this one here. Okay. And then there, 2 to 5. Okay, you have it there. And then when I create the circle, it was already aligned. So then you want to combine, you go here, Control, and then you combine, and you have one solid. So again, you can go here, you suppress from physics because we don't want that. The plane, you can hide it. Okay. You can hide here, and this is your solid. And then for instance, you can add an extra step. So curvature here, the fillet. So you go here again, pull, select this. It's very powerful. You can take geometries, any kind of geometry, and then just pull in and push, and you can do stuff like that. Okay, so we have this second geometry using the second software. Okay, so now it's up to you to choose which one do you want to use. Okay, so I close there, and let's move to the measure part. Okay, so I have it here. I will erase it. So I have all these geometries here. Okay, to show you the last step is like to import a geometry. You go here, geometry, right click, import geometry, and just select the geometry. So Workbench will take most of the standard CAD file format. So most of the time I use IGES or Parasolic. So you just look for the file. In this case, you see I read it, and then you can use any software to model. But when you do that one, I recommend you to use a Space Queen to modify the software, the geometry. Okay, let's say open the mesh. Okay, so you have your geometry, open the mesh model, and let's play around there. Okay, I already opened the geometry. I have the mesh. I did it previously. Let's go fast here. Okay, I think you got the idea. So you have the mesh, and see that we have this very nice mesh, and I will show you fast the control. So as you expand here, as user, remember, select physics preference. Okay, probably you have mechanical, put there CFD. Then in my case, I didn't add a method because by default it was taking the tetra mesh, but if you want, you can just force it, method, select the volume, okay, and use a method of your choice. So usually This one is a good one, tetrahedrons. Then add desizing. So, but okay, let me suppress this and this. Okay, so as you use the default options, you should have this, okay, which looks nice. So see that here it's doing automatically some refinement, but it's doing that refinement because you have some default options here in sizing. You see that it's got capture and curvature and proximity, no, just curvature. So to resolve this curvature is putting more cells, but let's use a body sizing. Okay, this one. Okay, and suppress, and see that I put that element size. Okay, and then also I force curvature, and by default, let me put it like this here. By default, you have 18 degrees. So as you generate this one, will be a nicer mesh because I have a smaller tetra defined. Okay, but still we can do better the curvature resolution. So this angle here that you have in curvature definition means that every 18 degrees put an element. So as you put here, for instance, 12, every 12 degrees put an element, okay, here in the perimeter. See, that is better. And let's put 6. This is the one that I was using. So it will have 30 elements here. It's 180 degrees divided 6, 30 elements. So you see that it's much nicer, the curvature. So you have to be careful, how to resolve, how to choose those values. Okay, so you put a value too low, it will put a lot of cells. So it's up to you. But remember, curvature needs to be well resolved. Okay, you have this. Remember, you can also add a surface refinement here as you want. The next step is use at the boundary layer. So remember, boundary layer, you will choose the volume, your whole volume. So remember, here selection have to be volume, and then where do you want to grow that boundary layer? Just select the surfaces, this. Okay, so remember, you will do control, and control, apply, and you selected your 4 surfaces, and now you will grow the boundary layer in the volume starting from those surfaces. Choose your values. So I would say I would use in this case the default values, but it's up to you to use something different. Okay, generate. And we're done here. So you press and see that very nice mesh, nice boundary layer. Okay, so you can do your math and see what is this. You want to have something well resolving. Okay, you have the equations and generate. You can get the distance from the wall to the first cell center. Okay, so we have this. So remember, before moving to Fluent, you need to create name selection. So here I already created. I have 5. Inlet 1, inlet 2. I have the outlet here. Then the walls. And then remember, this is a symmetry, so I call it symmetry. Okay, so Fluent automatically, if it sees an inlet, will put a velocity inlet, but that is automatic, something that Fluent does according to the name. You can also change it manually. Okay, so you should have this to check the number of cells. Remember, you go here in mesh, and at the bottom you have statistics, and we have this many. Okay, about 150,000 cells. So this is it. Okay. So now let's move. I will close, and then I will open Fluent. So remember, now I am opening Fluent. Just drag and drop Fluent. Remember, when you see the lighting, always update. So right click and update. That means that it will convert the mesh from this format to Fluent format. Okay, after a while it converted. Now that you have the mesh in the right format, you can double click here. We'll launch Fluent. Okay, yes. Okay, we'll load the new mesh. And remember, double precision and the number of cores. So now that we're going 3D, so put the maximum number of cores. Okay, so I will launch it, and let's wait a little bit. Okay, in my case, already open Fluent. So see that you have your mesh, beautiful mesh. So remember, first thing, always check the mesh quality. Okay. So see that is okay. So here probably this value is perfect. Probably 0.01 you can start to worry about the mesh, but usually if you follow good standard practices, you will get good quality meshes. Also, always check the dimensions of your domain. Okay, so here you have the scale. So as you create different dimensions here, you can do the scaling. So this is okay, this is the scale that we want, but always remember to do this when very often happens that you are importing from another software inches, meters, millimeters, whatever, and you get different values here, so it will give you strange results. So always scale to your right dimensions. Then remember is for instance in this case I will add as the previous one also temperature. So if you want to change units, okay, so here I think I already did it. So temperature, I'm working in Celsius, and let's do the case setup. So our vertical approach, pressure basic, then in models enable energy, you click there, enable energy, then turbulence model, so that any of this you want. So here you can go also less, okay, so less remain. Also a small warning, also it's not a good idea to use symmetry with less, okay, you know that you have all the scales, so probably it's better to do the whole geometry, okay, but it's not a problem. So I would work with the standard one, K omega C. Then materials, add the new material, water. Okay, so let me go here. Remember, I hope you remember how to do it. But also I want to show you something that is you enter in the library, you choose the element, for instance, water. You see that you have many properties here, many options here. So this depends about the models. You see saturation, pressure, okay, vaporizations, you are doing phase change. You have all these values and different models to simulate that, okay, but we're using the standard one, so you just copy, you get it there, okay. We have water, and remember just put everything constant, okay, or if you want to use something different, it's up to you. Then cell sun, okay, here, and choose your water, okay. So here probably by default is air, now put water, and if you have source terms or whatever, you will be able to set up that here, but in this case we don't have. Then boundary conditions, okay, so you go here and we have the inlet one, okay, so inlet one should be this one. So in your case, do this setup, so the velocity will be 0.4 as in the 2D case, okay, it's exactly the same, 0.4. Here also I put just for convenience 510, but if you want to put the hydraulic diameter, or if you have better estimate, it's up to you, okay. So 0.4 normal to that surface. The same for inlet 2, that will be 1.2, and I choose just intensity viscosity ratio. Then the outlet will be pressure outlet, and remember, okay, I forgot to mention that also in inlet you need to set thermal, so 20 Celsius here. Inlet 2 will be 40 Celsius. And then the outlet is a pressure outlet, okay, it's a Newman boundary condition, this one, use these values, these are backflow values, in the case that you have flow coming back is a specific treatment, so use the default temperature also, but if you want you can put there 30, okay. Then symmetry is symmetry, okay, so remember that, choose here. So if you use a different name there, probably it will be wall by default, but if you don't have that one, just put symmetry, and walls are walls, okay. So if you want a non-slip wall, you can put here a slip wall 000, or if you have thermal conditions, you can have heat flux. So heat flux 0 here is just adiabatic, but you can have also those values, or you can fix the temperature, okay, so you have all those models here. So we're done in boundary conditions. So we check here all these actions, we don't need to do anything. We go into methods, and for the time being, just go default, okay, and use the couple method. So for steady simulation, this is the recommended method, okay. For on a steady, you can use it, but it's very expensive, okay, use a lot of memory, and you won't see any improvement over over the other methods, the simple or piso, okay. Or the best one is the fractional stat, as the one that we use for the 2D cylinder case. So choose use the default options. You can leave it here first order for the turbulent quantities. Remember, it is the momentum. This one is all compulsory. You need to do it second order, and also energy. But turbulent quantities you can remain first order accurate. Control here, leave the defaults, but you know what is the effect of this on the relaxation. So later you can play with these values, but most of the time these values are okay. So report definitions. I created these report definitions same that we have in the 2D case. So I have one for the Y plus in the walls. Then I have the mass weighted temperature, if I will recall, yes, that the mass weighted average at the outlet. But in this case, I'm not doing the per surface. No, remember the per surface will plot. I know this is just for the outlet. I mean the mass flow. I also computed for the mass flow, but I'm not using the per zone options that I will plot, but for individual zones. Here we'll plot the summation of these 3 in 1, so it should be close to 0. Then go to monitors, residuals, standard residuals. Probably here you can put 100, okay, just to show less information there. Well, cancel. Save project. Okay, every now and then remember to save. And now in reports plots, you will have it there that you created here. So remember also that when you are setting the new report definition or monitor, for instance, remember to set if you want to save it to a file, if you want to report the plot. Okay, do not forget to add that. And then you go to convergence condition. So as we did for the to-do case, add one convergence condition. So I add in this one here. Okay, so I'm using this value, ignore the first 20 iterations and compute this for 20 iterations, do it every iteration. And I think we're done. Initialize, every initialization. So this one will give you a good initial condition. Or you can go and everything is steady, nothing moving. Okay, you can put everything 0, but I don't recommend. This one is much better. It will give you a nicer initial condition. Nothing calculation activities, and we can go here, run calculation, put there 1,000 iterations, use the default values. Okay, this is the one for the pseudo transit method, but use that default value. It's okay, and then go and calculate. Be careful, also check your memory. I think everybody have a decent computer now with at least 4 gigs of memory, because remember this will use a lot of memory. Okay, so here we have about 150,000 that can use up to 1 gig of memory just to run this one. So, but I guess you all have a decent computer. Okay, so see that we have the Y plus temperatures, the outlet. So see that this is much faster. As you recall the 2D that this is immediately going. Then the flows, let's see that it should stay within 0. So here probably you can also add another condition monitoring for the convergence. And here you have your residuals. So see that here is working, and after 20 iteration it's starting to compute those quantities. Here the condition. Okay, so it's very smooth, the convergence rate. Okay, everything is going fine. So let's wait for the solution. Okay, see that in my case the condition that we put is already converged, after probably 60 iterations, but still the residuals, they haven't converged. So remember, you need to fulfill both of them. So residuals and those conditions that are put in there. Okay, in my case, the calculation is complete. So it converged in about 167 iterations. So see that both conditions are fulfilled. Okay. And we're here as smooth. You see that mass flow here is close to 0, oscillating there. This one is also very stable, and my y plus is something about 8. So I cannot say it's wall resolving. Remember that if you want to go wall resolving, you need to resolve the wall. You need to put there a few compute nodes in order to resolve well the profile. So now let's do the post-processing. So the post-processing pretty much is the same. Okay, let me show you first report. So remember, report you can do many things a posteriori. So for instance, you can compute fluxes. You see here that it's balancing. Okay, it's conserving everything. So surface integrals, you want to compute something else. So for instance, let me do phase average and walls of pressure, and you have the values there. Okay, so very powerful this one. And then, well, now let's see the colors. So as you go here, contours. Okay, so I already have some predefined plots. So as you go here, see that. Okay, also probably I think you have something different. You see the reflection here in the bottom. I hate that. I don't like that. So as you go here in file, preferences, I think it's graphics. Okay, yes, here in graphic you see that probably you have all these options enabled, and you will see this. Okay, this honestly doesn't add anything to whatever you're doing. I probably can use more memory. So if you want, if you don't like it, disable. If you like it, leave it. But I hate that. I don't like that. Just leave the anti-aliasing. Okay, save displays, and the other option that you can go here in view, you can disable the lighting just to see better. Okay, that lighting also sometimes is difficult to see. Okay, so I have this. So see that we have here velocity in the cockplane. So see the solution, same boundary condition, but a little bit different from the 2D. So remember, 2D flows tends to be more energetic than 3D. So that's why you will see there higher velocities. Okay, so as you plot the outlets, we can see here the velocity distribution. Okay, and again you can play with all your variables. So you have temperature there. Okay, so see that distribution a little bit different from the 3D one. Okay, remember 2D from the 2D one. 2D cases are very energetic. And okay, you have everything. Again, you can go, let's take a look at the turbulent intensity. Okay, that people is asking for that. So you see that in this case I have fluctuations about 13%. Okay, so this I think makes more sense than the 2D were much higher. Okay, but instead, I don't like this. Can be misleading. Okay, this is telling you where the turbulence model kind of is kicking in. But if you want to get that information, so maybe look at the effective viscosity or turbulent viscosity. Here, you know that here you have that the magical quantity. No, the turbulent viscosity is the one that is adding the shear stresses, increasing the mixing and everything. So you get more information from there. Again, you can plot all the other variables. Okay, and let me go to show something else. So for instance, path lines, I haven't shown you this. So path lines, you go here is to release a string line. So I can say release string lines from the inlet. Okay, and okay, compute. Okay, I don't see the string lines. Why I don't see the string lines? Okay, I should see string lines somewhere here, but I don't know why. That is good. Okay, let me check this later. So let me go, for instance, vectors. So I want to plot vectors in these planes. Okay, here also is, I think I have a problem with, it's not updating. Let me see. Okay, dun, 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 dun. Okay, graphic surfaces. We have this one. I don't want this. Okay, if I go vectors there, I should see my vectors. Okay, yeah, I will. I think, yeah. Okay, sorry, it was in a different tab. Silly me. Okay, so you choose where you want to plot vectors. So see that it's relatively small. You can scale here. And you have your vectors, okay? Something interesting as well. You have a very nice way to plot. For instance, I want to plot the vectors in the outlet, but you can plot it tangential to the surface. You have here vector suction, and you go in plane, apply, and then you will need to scale, no doubt about that. Okay, see that these are in the plane. It's telling you the orientation in that specific plane. Very powerful. So remember, you have many options here, so play around, okay? And if we go back to the path lines, that now should be working. So where do I have that? Here, okay? So see, these are the streamlines that are following the flow. So the streamlines here by default, they are released from every single cell center. So if you have a lot of cell centers there, it will release a lot of streams and it might take some time to compute everything. So here you have the option to scale, for instance, 2, and then you have that, and you can change the color. So I want to by velocity, or you can go by temperature. Okay, so this is the path that particles release, massless particles are following. Okay, so we created streamlines, this vector plot. Let me create another nice one that I have. You create a new one, and you select the walls, and you have all floor lines. So it will create Okay, release from there and symmetry, and then you want to create flow lines on walls and symmetry. Okay, so this one sometimes can take a time. So I'm releasing a lot of lines and then constrain those lines to the surface, so kind of you can see how the direction that the flow is following attached to the wall. Okay, see that you have it here. So maybe I put too many. Let me put a skid to one to reduce. So be careful that sometimes you, okay, yeah, probably also you don't put it in the symmetry plane. It's a symmetry, so it doesn't make sense that to put it there. Okay, see that here. You can see, for instance, this one can give you a good indication where do you have separation. Okay, look at that. This is a nice part. I really like this. Okay. So see here that you have some recirculation. Okay. So we went through all and then the vectors. Okay. We have that vector constraint, create a new one. So see that we're creating many objects there, and we'll show you something else later. And let me put vectors also in symmetry and on walls. And scale 5. Okay. Okay, so you have your vectors as well there. We have cog planes. Okay, so also remember that we can create some other planes in the volume, in the 3D volume, but I will show you another option. Is you go here, and should be animation somewhere, if I will recall. Okay, here, animation. You have sweet surface. You go edit, and you can create a surface that you can see here. So I want that surface, let's say normal to X, okay, and then just play with this slide bar, and then you have it there. Okay, done. So properties, then you can see, you can choose what you want to visualize there. So you can, I want to see contours there of what velocity, put it there. Okay, so fill. Okay, and you have it there. Okay, so you can do it interactively. Okay, and you can put any variable there, so you can change also the plane. So now let me do it here, and 1 0. You compute, and then you move, and then you have it there. So this is interactive. If you want to create one plane there, just create, and we create this surface and so on. Okay, then you have this auction animation, increase the number of frames, and we'll do an animation. Okay, what else I can show you? Okay, just to end, let me show you, well, not to end, two things I want to show you. You have also here a scene. Here you can combine all these objects that you created here. You can combine. You see that, for instance, in this tab, you can only see one thing. You can go here and I want to see contour, the vectors and the path lines, save and display. And it will create your scene there. See that all the objects that you put there, you have it in this combined scene. Okay, probably this one is time consuming. Okay, this one also is powerful. Okay, you can add, for instance, the contours. You can add some transparency. Okay, whoops, save and displays. You see that transparency. You have these bars here. So what you see here, all this bar you see here, is because you have it in the original object that you created. So if you want to hide one bar, you can go, for instance, contour 1 here and color map options. I don't want to see the color map. You see that you hide it there. Okay, so whatever you do here when you create these objects in results, then you can combine it in a scene and can put everything together. Very powerful. Okay, the last scene that I want to show you is to do the mesh refinement. Remember that we did it in 2D. Let's do it in 3D. Exactly the same that we did, but I'm not going to run the simulation. It's up to you. So you go new. I want to create field variable. It will be temperature, static. I want 1000 range, compute to know the values. So I will go from 30 to this and save and display. It's giving you this warning that it's not showing you all the cells just to make it fast, and see that you are adding that there. Okay, I close. You have your field there, and then you right click and you refine. It will do the refine. Remember, previously I accessed that there, and now I right click and you have it. So see here that you already have the information, and let's visualize the mesh, and you will see that now we have tetra. Okay, and you will see that also with tetra it works, but you will see that it uses a different algorithm. Okay, see what it's doing. Okay, it's creating polyhedral cells there. Okay, so Fluent also have a very powerful meshing tool, and that meshing tool is based in these polyhedral cells, which in theory are the best ones. Okay, well, this is a matter of religion, but they are very powerful. They have very good properties. So let me create now a surface and okay, properties. Okay, we are mesh properties. Okay, let me choose something else. Okay, symmetry. Okay, contour. Why? Okay, we are there. I want to see the mesh. Okay. Well, leave it here. Properties, following surface. Okay, it's not a problem. It's telling me draw mesh. I want to see. I don't want to submerge there. Okay. Okay, it's not creating. Let me go here. Give me a minute. Okay, I will create a seed surface there, and I will plot now the mesh there. Dun dun. Okay, why bam 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 lighting? Okay, sometimes light, and see here that we have the refinement also. I think we did the refinement also in the boundary layer. Let me see. 1, 2, 3, 4, 5. No, it didn't do it in the boundary layer, but you can also select in the text using interface to do it there. Okay, so I think that's all that I wanted to show you here in this case. As you see, the post-processing is very powerful. Then you can move to CFD post if you want, but as I told you, I'm not very happy with that one. I don't like it, but it works well as well. So I think these were basic tutorials. Okay, now from now on we're going to move to more specific tutorials to Turbulence, stuff like airfoils or pipes where you have separation, and then some geometries to less. But we have all the, at this point I think we have all the fundamentals. Okay, so thank you for your attention. See you next time.